Hi listeners, you're welcome to the continuation of our online physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAM, WAEC, NECO, and NAPTIP exams. For today's presentation, we shall be discussing the concept of prayer. I am Bangbade AA. Now, before we continue, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to define prayer. They should also be able to define atmospheric prayer. They are also expected to be able to state the formula for calculating prayer. And lastly, they should be able to solve relevant UTME questions relating to prayer. Now, by prayer, we mean a natural force exerted on a unit area of a surface. I repeat, prayer is the natural force exerted on a unit area of a surface. The prayer P at density D is given by P equals HdH. I repeat, the prayer P at the density D is given by P equals HdH. P in this case represents the prayer, H represents the height in meter, D represents the density in kilogram per meter cube, Yg represents the acceleration due to gravity in meter per second square. Alternatively, the prayer P can be calculated by using the equation P equals force F in Newton over area A in meter square. I repeat, alternatively, the prayer P can be calculated by using P equals force F in Newton over area A in meter. Now, also, we're to know that prayer depends on density and height. Of course, you know from the first formula we said prayer equals height times density times acceleration due to gravity. That means prayer will depend on this parameter of density and height of a liquid column and not on the shape of the container or total volume of the liquid. So prayer does not depend on the shape of container or total volume of the liquid. Having understood that, we are also to take note that prayer acts in all directions. I repeat, prayer acts in all directions. And lastly, we are to take note of the unit of prayer, which include Pascal, usually represented as PA, then atmosphere, usually represented by ATM, then Newton per meter square, that is Nm raised to power minus 2, etc. Now on to the concepts of atmospheric prayer. The Earth, were to note that the Earth is surrounded by an air belt referred to as atmosphere. The atmosphere is several kilometers high. Then, when we now talk of atmospheric pressure, it may be defined as the weight of air which is supported by a unit area of the Earth's surface. I repeat, atmospheric pressure may be defined as the weight of air which is supported by a unit area of the Earth's surface. It decreases with altitude. So the higher you go, the lower the value of atmospheric pressure. It decreases with altitude or height. By altitude, we mean height above the sea level. Now, 1 atmospheric pressure is approximately 1.0 times 10 raised to power 5 Pascal. PA means Pascal, or 760 millimeter mercury. I repeat, 1 atmospheric pressure is equal to 1.03 times 10 raised to power 5 Pascal, or 760 millimeter mercury, and this is referred to as 1 atmosphere. Now, having understood that, we are also to take note that the atmospheric pressure of 1 atmosphere is equivalent to the pressure which is exerted at the bottom of a mercury column of height 760 millimeter, or water column of height 10.3 meter. I repeat, the atmospheric pressure of 1 atmosphere is equal to the pressure which is exerted at the bottom of a mercury column of height 760 millimeter, or water column of height 10.3 meter. Now on to sample questions from the UTME. And the first question we shall be considering comes from 1993, number 10. And the question goes thus: a weightless vessel of dimensions 4 meter by 3 meter by 2 meter is filled with liquid of density 1000 kg per meter cube and sealed. What is the maximum pressure this container can exert on a flat surface? We are given in brackets that acceleration due to gravity g equals 10 meter per second square. Then we are given option A to be 9 times 10 raised to power 4 Newton per meter square. Option B is 4 times 10 raised to power 4 Newton per meter square. Option C is 3 times 10 raised to power 4 Newton per meter square. While option D is 2 times 10 raised to power 4 Newton per meter square. Now on to solution. The first step is to write out the given parameters, and from the question we are given that the height is 2 meter. Then we are given the density to be 1000 kg per meter cube. Of course, you know that is the density of water, so it's either 1000 kg per meter cube or 1 gram per centimeter cube. Then we are also given the acceleration due to gravity g to be 10 meter per second square. So here now we have to record that the pressure equals dgh, that is the product of density times acceleration due to gravity times height. And if we substitute for that, our pressure P will be equal to D, which is 1000 kg per meter cube, times G, that is times 10, then times H, which is 2 meter, and that will give us 2 times 10 raised to power 4 Newton per meter square, making option D the correct answer for this particular question. Now the next question we shall be considering comes from 2002, number 8, and the question goes thus: the hydrostatic blood pressure difference between the head and the feet of a body standing straight is 1.56 times 10 raised to power 4 Newton per meter square. Find the height of the boy. We are given density of the blood to be 1.1 times 10 raised to power 3 kg per meter cube. Then we are given the acceleration due to gravity g to be 10 meter per second square. Then the option A is given to be 0.6 meter, option B is 0.5 meter, option C is 2.0 meter, while option D is 1.5 meter. Now on to solution. The first step is to write out the given parameters, and from the question we're given the pressure to be 1.56 times 10 raised to power 4 Newton per meter square. We're given the acceleration due to gravity to be 10 meter per second square. Then we are given the density of the blood D to be 1.1 times 10 raised to the power 3 kilogram per meter cube. Why the height H is not given? Of course, that is the one they asked us to find. Now we have to recall that we said the prayer equals dgh. That is the product of density, acceleration due to gravity, and height. So if we substitute for this, our pressure is 1.56 times 10 raised to the power 4 Newton per meter square, which is now equal to the density, which is 1.1 times 10 raised to the power 3 kilogram per meter cube, then times acceleration due to gravity g, which is 10, times h, which is unknown. Of course, we can make h the subject of formula by dividing through by the value of density and g. So by dividing through by 1.1 times 10 to the power 3 and times 10, we get our h to be 1.56 times 10 raised to the power 4 Newton per meter square over 1.1 times 10 raised to the power 3, then times 10, and that will give us 1.5 meter, making option D the correct answer for this particular question. The next question we shall be considering comes from 2004, number 32. And the question goes thus: a man exerts a pressure of 2.8 times 10 raised to the power 3 Newton per meter square on the ground as 4 times 10 raised to the power minus 2 meters square of his feet in contact with the ground. The weight of the man is dash. So we're given option A to be 112 Newton, option B to be 140 Newton, option C to be 102 Newton, while option D is 70 Newton. So now on to the solution. The first thing is to write out the given parameters, and from the question we're given the pressure P to be 2.8 times 10 raised to the power 3 Newton per meter square. Also we're given the area to be 4 times 10 raised to the power minus 2 meters square. Then they ask us to get the weight of the man, which is a force. That is unknown. For this particular question, we can use the formula of pressure that says P equals force over area. I mean, pressure P equals force F over area A. Then, since force is what you want to find, you can cross multiply to make force the subject of formula, and that will give us F equals PA. That is, force equals pressure times area. So if we substitute for that, we have force equals the pressure, which is 2.8 times 10 raised to the power 3, then times area, which is 4 times 10 raised to the power minus 2, and that will give us 112 Newton, making option A the correct answer for this particular question. Now, the next question we shall be considering comes from 1997, number 18. And the question goes thus: a liquid of mass 1.0 times 10 raised to the power 3 kg fills a rectangular tank of length 2.5 meter and width 2.0 meter. If the tank is 1.4 meter high, what is the pressure at the middle of the tank? You have option A to be 1.0 times 10 raised to the power 4 Newton per meter square, option B to be 2.0 times 10 raised to the power 3 Newton per meter square, option C to be 1.5 times 10 raised to the power 4 Newton per meter square, while option D is 1.0 times 10 raised to the power 3 Newton per meter square. So you are given G equals 10 meter per second square. Now on to solution. The first thing is to write out the given parameters. And from the question we are given the mass to be 1.0 times 10 raised to the power 3 kg. We are also given the length to be 2.5, the width to be 2 meter, and the height to be 4 meter. The height is 4 meter. Then if you want to get the volume The following will be length times breadth times height, and that will be 2.5 meter times 2 meter times 4 meter. That gives us 20 meter cube. Since we have been given the mass in the question and we've calculated the volume, then we can get density from the mass and volume by using density D equals m over v, that is mass over volume, and that will give us m, which is 1.0 times 10^3 divided by volume, which is 20 meter cube, and that will give us 1000 divided by 20 will give us 50 kilogram per meter cube. Now we have to recall from the question that we are given acceleration due to gravity g to be 10. Then the question now says what will be the pressure at the middle of the tank. So if the tank is 4 meter high, then the middle will be 4 divided by 2 meter. Then we can proceed to calculate the pressure now using the formula that says pressure equals density D times acceleration due to gravity g times h, that is pressure equals dgh. So if we substitute now, our density D is now 50 times g, that is acceleration due to gravity, which is 10, then times h, which is now 4 over 2, that will give us 2, that is half of the tank. Then that will lead us to 50 times 10 times 2, which is 1000. 1000 can be expressed in standard form as 1.0 times 10 raised to the power 3 Newton per meter square, making option D the correct answer for this particular question. Now on to practice question, and the first question we brought for your practice comes from 2013 number 4, and the question goes thus: at what depth below the sea level would one experience a change of pressure equal to 1 atmosphere? Then we are given option A to be 0.1 meter, option B to be 1.0 meter, option C to be 10.0 meter, while option D is 100 meter. Then you are given the density of the sea to be 1013 kilogram per meter cube, while 1 atmosphere is given to be 1.0 times 10 raised to the power 5 Newton per meter square, and G is given to be 10 meter per second square. So expected answer here is 1.0, which is option B. Then the next question, which is also for your practice, comes from 1990 number 13, and the question goes thus: what is the length of the liquid column in a barometer tube that will support an atmospheric pressure of 102,000 Newton per meter square if the density of the liquid is 2600 kilogram per meter cube, then and acceleration due to gravity g equals 10 meter per second square? So you are given option A to be 0.75 meter, option B to be 0.76 meter, option C to be 3.92 meter, while option D is 39.23 meter. Expected answer is 3.92 meter, which is option C. Now, our next video will be on transmission of pressure with sample questions and solution from the UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures and presentation relating to UTME subjects, especially physics. Thank you.